I recently asked a group of Chinese medicine practitioners and educators from all over the world how they would define the character qi. The answers were far ranging, from energy to life force to love, function that is a metaphor that you can't define it at all. Some people said that it means ATP or oxygen. One person even shared this quote that they said was from Einstein: "Everything is energy and that's all there is to it." Now, Einstein never said that, but even if he had, that still wouldn't answer what qi is. But the popularity of this type of response kind of points out the problem that we have, that even people who use medicine based on this concept can't even remotely agree to what it is. Then my skeptical cousin weighed in, and he defined it this way: "It's an ambiguous ancient Chinese qualitative health energy metric, mostly useful for marketing." Qi is foundational to all of East Asian medicine and is the most used character in the Huangdi Neijing, or the Yellow Emperor's Inner Canon, which is the classical text on which all of Chinese medicine is based. It is used 3,009 times in this text. That's about 250,000 characters long, and is foundational to this clinical framework, which is actually the most tested clinical framework in the history of humans. And yet the practitioners can't even agree on what it is. So we have all of these common descriptions like that qi is energy or life force, or that it's function, but we're lacking a true physical referent. And so we're getting all these contradictory responses. And when things are like that, then my cousin's response actually starts to seem quite reasonable. But the reason for the confusion isn't that qi is untranslatable. It's basic physics that hasn't been commonly taught in standard education, in medicine, or anywhere else. So you're probably familiar with the three standard states of matter: gas, liquid, and solid. But there's actually a fourth state of matter, and this is called plasma. According to Princeton University's Plasma Physics Lab, plasma makes up 99% of the visible universe. Plasma is basically electrically charged ionized gas, so molecules with their electrons stripped away. And plasma is not controversial in physics. It's actually well established. It's just not commonly taught for some reason in standard education. Some examples of where we find plasma in things we're familiar with: the sun is a plasma, lightning is, the northern lights is a plasma, solar wind, fire itself is actually a plasma. The air itself, the air you breathe, is weakly ionized, and so it is a weak plasma. So when you breathe air, you are interacting with plasma, and you are basically breathing in electricity. So plasma itself isn't exotic because it makes up 99% of the known universe. Actually, what's more unusual is what we're actually more familiar with, which are solids, liquids, and gases. A researcher by the name of Hans Alfven won the Nobel Prize in Physics in 1970, and he said space is filled with a network of currents which transfer energy and momentum over large or very large distances, likely giving space a cellular structure. So here he's talking about plasma. This network that's moving through space moves through everything, including you. Once you see it, it's really hard to unsee it, and everything looks different, including 2,400-year-old Chinese medical texts. Now, one clarification I want to make is that the plasma that we are talking about is a little bit different than what we're more familiar with, which is blood plasma, which is the liquid fraction of blood when you remove the red blood cells. And that's actually a related concept to the physics definition of plasma because it's an ionized liquid, but it's not identical, it's just related. What we're talking about here is something that's more fundamental and more universal. So in addition to solid, liquid, and gas, we have a fourth state of matter that's called plasma, but there's actually a more foundational fifth state of matter that gives rise to plasma. And this is called different things by physicists: the zero-point field, or the Higgs field, or just the grid. And I actually came across this idea reading a book by researcher and author Eileen McCusick, she refers to it by its original name, which was ether. And so ether is the most foundational state of matter, and when things move through it, it gives rise to a current and spins into plasma. So the movements that generate plasma from ether tend to be torsional or rotating, spinning, spiraling. This creates charge and differentiation that we recognize as the physical world, and is consistent across scales from subatomic spin to the spiral of galaxies. According to Nikola Tesla, ether is an ocean of clear light through which all waves travel and the field of infinite potential. Ether has a bit of a complicated history. It was the accepted universal medium that gave rise to all of reality, all of physical reality. But in 1905, Albert Einstein published his theory of special relativity, and in that he argued that we didn't really need ether anymore. And coupled with an experiment that was called the Michelson-Morley experiment that failed to detect ether, the idea was largely abandoned and became less popular, but it never really went away. So first, that experiment has actually been shown to be really flawed and wasn't really good evidence that ether didn't exist. Though really, the concept remained, but physicists just started calling it other things, like the zero-point field. Einstein actually changed his mind about ether not existing and realized that it needed to exist in order to explain how the physical world works. And in 1920, in a lecture at Leiden University, he said, "Space without ether is unthinkable, for in such space there not only would be no propagation of light, but also no possibility of existence for standards of space and time." So really that we don't have just a vacuum where there's nothing there, it's that we have an ether. And he wasn't alone. Nobel Prize-winning physicist Paul Dirac wrote in Nature in 1951, "With the new theory of electrodynamics, we are rather forced to have an ether." And as recently as 2019, the New Scientist headline read, "Einstein killed the ether, now the idea is back to save relativity." So the full continuum of the fabric of reality is ether, plasma, gas, liquid, solid. Nothing stops being what it came from. Now you might be wondering what all this has to do with 2,400-year-old texts, and what's remarkable is that classical texts from this period describe the same exact continuum of the fabric of reality. And not as a metaphor, but really specific and precise in their language. There's a classical text called the Huangdi, which was written about 150 BC, and it gives a universal definition of qi like this: "The Tao arises in emptiness. Emptiness generates space and space and time generate qi. Qi has a boundary." So it's this impulse to move through empty space that creates qi. Qi is the fabric of space-time, and everything that we can see, touch, hold, and measure arises from this fabric. And this description that qi has a boundary shows that it's the first level at which we have any sort of differentiated stuff. Everything that follows, that's solid, liquid, and gas, is qi operating at different densities. Now, the Neijing itself also describes this in Suen chapter 66. "In heaven it is qi, on earth it becomes form. Form and qi stimulate each other, and through this transformation generate the 10,000 things." The 10,000 things is like all the things, right? So in the heavens, it is qi, and in the earth, it is form. And in the Neijing, form is anything that casts a shadow. Then there's another description in Neijing Suen chapter 9 that says, "Qi combines and takes form. Through transformation, names are established." So what they mean is like names or things, right? Differentiation, not the things that we can't see but can sense, but the things that we can actually point to and name. So qi is the generative substance from which all of the things that we can name come. Now, I want to say that this connection that I'm making between qi and ether and plasma is just sort of my own noodlings, and it's possible that the definition of qi doesn't map perfectly onto those things. But I find that being aware of the existence of plasma and ether helps me understand what the text is describing a lot better, and the parallels, and especially including the progression of things starting off as more etheric and becoming more solid from the same stuff. Those parallels are pretty hard to ignore. Now, for more information on the text called the Huangdi Neijing that was written 2,400 years ago, you can check out my previous video in this series that goes into why it's important, what it contains, and why almost no one has read it. If we look at the character for qi, the pictograph, we can get a lot of information about the concept trying to be conveyed here. So in its earliest form, from oracle bone and bronze inscriptions that were made over 3,000 years ago, we see it showing vapor or steam rising. So something subtle and moving upwards. And so this is the most fundamental end of the continuum. So this is really more the etheric end or the plasma end of the matter continuum. Later on, the rice radical was added to the qi pictograph. And so now we have this idea that maybe we're talking about something nutritive, but also we're talking about something that's solid that gets boiled in water and that steam rises up, and that steam's not just containing water, but it's also containing nutritive substances. But the idea that really strikes me is that it's really encoding a phase transition in this character, which is really interesting. So if everything is arising from condensation of this fundamental substance, then we can start to understand a little bit better why the Huangdi Neijing uses the character qi 3009 times. Now, Dr. Ed Neal, who's a medical doctor and Neijing scholar, he's pioneered this method of research called text archaeology, where using the digitized text, we can ask certain questions in ways that we never could before. And one of the things that he's pulled out is that the Neijing contains hierarchical definitions. And that means that there are definitions that are universal and that are what a character might always mean. And then there are definitions that are more contextual. They're smaller definitions. And so lower down in the hierarchy. And so this is definitely true for qi. What I mentioned earlier, those quotes, those are part of the universal definition of qi, where we're talking about qi as the fabric of space-time. When we look in the body, then we can see all these specific examples of qi and how it's used in different contexts. So one of the confusing things is that people are trying to understand qi without a precise physical referent. And another misunderstanding is that they're not aware of the use of hierarchical definitions. And so many of my colleagues answered that the definition of qi depends on where you're looking, and that's sort of right, but it misses that there is a big universal definition as well. So the Neijing describes things like lung qi, defensive qi, nutritive qi, heavenly qi, grain qi, rebellious qi, and so on. These are not contradictions. We're talking about the same substance that is taking different forms depending on where we're looking. So if we look at some of these more contextual uses in the Neijing, one example is from Lingshu 47 that reads, the channel vessels are the means by which blood and qi moves. The Neijing describes the channels as being analogous to rivers that you can find in nature and actually compares each of the channels to actual rivers that you might find in ancient China. We see that blood and qi are moving through them, and the original referent here was almost certainly the vascular system, the blood vascular system of the body. And it's likely only later on, after the text was originally compiled, that this idea of the channels being something that are unsubstantial arise later. If we look at another example, we can see that qi doesn't always travel in the channels, right? So here's another quote from the Neijing Lingshu 30 that describes a different action. It says, the upper burner opens and diffuses. The upper burner is the area of the body above the diaphragm where you have the lungs and the heart. And it says it opens and diffuses, spreading the flavors of the 5 grains, fumigating the skin, filling the body, moistening the hair, like mist and dew, irrigating the land. This is called qi. So in this example, we see qi that's not going through vessels with blood, but actually fumigating and misting, which is what that character here means. And it's a very different action that's actually very similar to a more recent discovery of how gases work in the body that we're going to look at in a moment. But qi isn't just in the body either flowing through rivers or misting it. We're also embedded in a natural context, right? We're part of nature, and we have qi all around us that's acting on us, and we see a lot of descriptions of that as well in the Neijing. Here, there's one definition of qi that reads, 5 days constitute 1 hu, 3 hu constitute 1 qi, 6 qi constitute 1 season, 4 seasons constitute 1 year. So what does that mean? So here they're defining qi as a unit of time, but time was always with reference to where the sun is, whether that's during the day or during the year. And so it's fairly obvious that depending on the time of year, conditions like atmospheric pressure and humidity and overall climate, solar angle, particulates in the air, all these things that are invisible but very relevant are going to be changing depending on the time of year. And so they're defining a specific unit of measurement where there's a meaningful change in the qi depending on what time of year it is, which is really interesting. And modern Chinese medical practitioners will adjust their treatments depending on the time of year and the season, and even sometimes depending on the time of day. So we've established that plasma comprises over 99% of the known universe. And modern medicine has completely missed this and really struggles with working with anything that's not physical and tangible. But modern research has actually made two sort of fundamental discoveries that are both almost their own fields that really map directly on to both how chi is described and also what we know plasma is. And those are to do with bioelectricity and something called gasotransmitters. So gasotransmitters are gases in the body that diffuse through membranes. They don't need a transmitter, and they've been found to be super fundamental to how the body signals and regulates itself, and is playing a big role in the immune system, in how the blood vessels are behaving. In 1998, the Nobel Prize in Medicine was won by a researcher who discovered that nitric oxide was playing a really fundamental role in the tone of blood vessels. So it's a relatively recent field, and it was largely ignored for a couple of reasons. Gasotransmitters have a very short half-life, so they're very difficult to measure, but also we've inherited this worldview from the Rockefeller Better Living Through Chemistry thing that really hyper-focuses on chemicals going through a medium and largely misses something like gases diffusing through a membrane without a need for a receptor. So it's really breaking out of that paradigm. But a 2012 textbook on gasotransmitters says the advent of gasotransmitters has profoundly changed our way of thinking about biosynthesis, liberation, storage, and action mechanisms by cellular signaling. So in other words, if you aren't aware that these are there, you're missing a huge piece of context of how biochemistry even works in the first place. Now, since the discovery of the central role of nitric oxide, a couple other gasotransmitters have been recognized. One is hydrogen sulfide and another is carbon monoxide. And these were both considered to be toxic to humans, but now we know that they're actually an important part of health, which is really interesting. So these gasotransmitters, these molecules, are not minor players. They are playing a central role in mitochondrial regulation and neurotransmission and pretty much anything else that you could think is important. And yet almost no doctors have been taught about them or aware of their existence. So gasotransmitters are gas phase signaling. They're misting through membranes, and they're a primary aspect of life and of regulation. And because they're at the more invisible end of the spectrum, they're so far not incorporated into the modern medical model. Now, the second new framework, right, that isn't part of modern medicine yet is this concept of bioelectricity. Now, modern medicine recognizes that bodies have electricity. If your heart stops, they're going to shock you back into sinus rhythm, and they will measure your electrical rhythms with an EKG or an ECG. They'll measure your brain rhythms with an EEG. So they're aware that there's electricity there, but what's missing is an understanding of an electrical network in the body that is fundamental and gives rise to almost all the other things that they're looking at. And this is a big oversight, and there's increasing evidence for this, but again, it hasn't filtered in to mainstream medicine yet. Now, there was a researcher working mainly in the 1960s through the 1980s named Robert O. Becker. He wrote a book called The Body Electric in 1985. I remember first reading this in about 2010. Really interesting that he was able to demonstrate that the body has a direct electrical current system that's operating foundational to nerve transmission and pretty much everything else that's happening. And he was able to elicit wound repair of non-healing wounds and fracture healing of non-union fractures, and even getting salamanders to regrow limbs. In 1979, his funding was removed and his lab was shut down because he started to speak about the potential harms of man-made electromagnetic radiation. So we lost that thread. Now, more recently, there's a researcher at Tufts named Michael Levin, super smart guy, who's been doing all sorts of interesting things, including manipulating bioelectricity. He's been able to do things like get frogs to grow a functional working eye just by manipulating the voltage gate channels in a certain area. So he's not changing the DNA at all. He's just changing the electricity and how it's signaling there and getting new body parts to grow, which is completely at odds with the current paradigm that's used in modern medicine. Michael Levin says, we've been trying to do medicine by editing the hardware. What if we just rewrote the software instead? So instead of looking at the stuff, look at the electrical signaling instead. Now, some of these ideas were anticipated by a doctor and researcher named Harold Saxton Burr back in the 1940s and 50s, working out of Yale. He was able to measure and detect a weak electromagnetic field around all living beings. He called this the L field. And researcher and author Eileen McCusick, she's been working with this as well clinically, and she describes that humans have a double membraned weak bioplasma field around their body. So these newer ideas that are anticipated both by understanding this missing physics that, none of us were taught, and then also tie it back when we look at how qi is described, we see a lot of parallels. But these ideas of the fundamental role of gasotransmitters in the body on the one hand and bioelectricity on the other make up the two key aspects of what plasma really is. So if we go back to the answers that I got to that question, when I asked, we got these different types of answers of qi is energy, or qi is unknowable, it depends, qi is love, qi is the force. And all of the answers really fit into a few categories. And they're all pointing to something real, but they all got different pieces of the elephant, right? So probably the most common one is this idea that qi is energy. And really, if we understand that qi is defined as the fabric of space-time, then the clearest way that I understand it, which comes from my teacher, Dr. Ed Neal, is that qi is the ocean, it's not the wave. So the wave is information coming through, and a wave contains energy, but it's not the water. Qi is the water. So this is clear in the text, and this hopefully clears up some of that misunderstanding. So and another set of ideas was trying to reduce it to something measurable like ATP or oxygen. One practitioner said that qi is everything that's on a blood test. And so this is really missing most of the bigger definitions, right? So everything that we can touch or measure is made of qi, but if we just leave it at everything, then the definition's a little bit too imprecise. So if we understand it as the fabric of space-time through which all things condense into, then we're closer to the idea that's being described. Then another category was saying that qi is just a process or a metaphor. This is not what the text says. It says that qi is flowing through vessels and that it can be spilled out and that it's doing specific things. And so the text that's explaining qi is not pointing to a function. It is actually pointing to a substance that it's describing pretty clearly. And then the third category is that qi is ambiguous, or the definition is contextual. And that the definition is contextual is sort of right, but what's really missing is that physical referent, that original physical referent, and also this understanding of the hierarchy of ideas, that qi at its most fundamental is the fabric of space-time, and then that can take different forms in different contexts, but we still have definitions of what qi is, and it's not that it can't be defined, because it is defined in a number of places. So qi isn't mystical, and it's not a metaphor for function. It's what classical traditions named the full continuum of physical reality. In living systems, we now know that ionized gas and electricity play fundamental roles, foundational to what's normally looked at, and these are both fundamental aspects of plasma. So when we start to see a lot of missing ideas, really important ideas from the more dominant worldview, then the way qi gets described starts to make a lot more sense. 2,500 years ago, classical Chinese physician-philosophers described the fabric of space-time and the full continuum from the most diffuse substances and what the universe is made of all the way through to solid, liquid, and gas. And they developed a clinical framework on it, which has been used and tested for millennia, that's based on a text that uses this character, qi, 3,009 times. When you become aware of the full spectrum of physics that includes plasma and ether, the parallels become pretty striking and pretty clear, pretty interesting. Once you understand what the universe is really made of, the idea of qi starts to make a lot more sense.